Good morning, students. As we all know, we are dealing with the chapter P block. We already did the oxygen family and oxygen family members. Today, our topics are production of sulfur dioxide, its structure, sulfur dioxide, contact process. Through contact process, we are going to produce sulfuric acid. After that, we are dealing with oxo acids and allotropes of sulfur. Now, so we start with production of sulfur dioxide. See, sulfur remains in its allotropic form, that is S8. When the S8 is burned in excess of air, the sulfur dioxide is formed. Second method of production of sulfur dioxide is when the ferrous sulfide is heated with excess of air, again sulfur dioxide gas is produced. Decomposition of calcium sulfate is also helpful for the production of sulfur dioxide. Now, the properties of sulfur dioxide. See, first of all, we are dealing with the structure of sulfur dioxide. When we are drawing the structure of sulfur dioxide, it's forming angular structure, sulfur having lone pair, so its structure is angular, or we can say that its structure is bent shape. As sulfur dioxide can form its resonating structure, so that bond length between the sulfur and oxygen remains in both cases. I am again repeating, the bond length of sulfur and oxygen remains same in both cases because there is a presence of resonance in sulfur dioxide. Now, the properties of sulfur dioxide, it is a colorless gas having rotten egg smell, highly soluble in water, easily liquefies. Sulfur dioxide dissolve in water and helpful for the production of sulfurous acid, which is an oxo acid and having acidic character. So now the chemical properties of sulfur dioxide. See, as we have studied that the sulfur dioxide is soluble in water, so it dissolves in water and forming the sulfurous acid, and formula of sulfurous acid is H2SO3. It does not support the combustion, and the very important property that sulfur dioxide is a strong oxidizing agent as well as it is a strong reducing agent. When it reacts with H2S gas, it is acting as a oxidizing agent. But when it is react with water molecule, it acts as a reducing agent. Now, the sulfur trioxide, and the formula of sulfur trioxide is SO3. See, student, SO3 is produced when SO2 is burnt in with air with the help of catalyst vanadium pentaoxide. The presence of catalyst vanadium pentaoxide is necessary for the production of SO3, and secondly, it is an exothermic process. So students, if it is asked, mention any three methods by which the production of SO3 is increased. So the first, we apply the Le-Chatelier principle, and according to Le-Chatelier principle, if we need the production of products in higher amount, the concentration of reactant must be high. So the first, if we increase the concentration of SO2 and O2, automatically the production of SO3 is increased. As this process is exothermic, the heat is releases minus 196 kilojoule per mole. So exothermic reaction always support at low temperature. And the third, what is the effect of pressure? And we require high pressure or low pressure. See, number of moles of products is 2, and whereas number of moles of reactants are 3. So by increasing the pressure, reaction goes forward direction. So if we summarize, then the three methods are for the increase of production of SO3. Number one, increase the concentration of reactant. low temperature, because exothermic reactions are favored at low temperature and high pressure. The production of SO3 gas is responsible, and it is also helpful for increase the production of sulfuric acid. This is the key point of production of sulfuric acid. Now, production of sulfuric acid is also called as contact process, and the raw material which is required for the production of sulfuric acids is sulfur trioxide, as I mentioned earlier, sulfur dioxide and sulfur trioxide. Sulfur dioxide is converted into sulfur trioxide within the process, air, water, and catalyst. And name of the catalyst is vanadium pentoxide. Now, industrial process of production of sulfuric acid, it is also called as contact process. See, first of all, we try to discuss with the help of reactions, chemical reaction, then we move to the diagram part. See, at first point, sulfur, crude form of sulfur, powdered form of sulfur, react with oxygen and give the production of sulfur dioxide. And that sulfur dioxide is converted into sulfur trioxide with the help of catalyst as vanadium pentoxide. Now, sulfur trioxide is converted into concentrated sulfuric acid. That is, first, it is obtained in the term of our oleum. This is the concentrated form of sulfuric acid. When the concentrated form of sulfuric acid is diluted, the sulfuric acid is formed. Why it is called as contact process? Because the molecules of oxygen and sulfur dioxide attached to the surface of solid catalyst vanadium pentoxide remains in the contact of solid catalyst vanadium pentoxide. So the process is called as contact process. Now we are going to discuss diagrammatically. See, in first chamber, in shelves, sulfur is present and air is coming. Sulfur reacts with air and give the production of SO2 and some unreacted oxygen. Move to the another chamber, that is our second chamber. Here water spray is done. Water spray is done for the suspended impurities, to remove the suspended impurities. Now this moistened gas, because water spray is there, is moved to the another chamber where concentrated sulfuric acid is sprinkled over this moistened gas. As we all know, sulfuric acid is a very good dehydrating agent. So it dehydrates the moistened gas and convert it into dry sulfur dioxide and unreacted oxygen. Then it is moving to the arsenic purifier. Then it is moving to the main chamber where the catalyst vanadium pentoxide is present, where it is converted into SO3. Sulfur dioxide is converted into SO3, and when the SO3 move to the chamber where the spray of sulfuric acid is done, it is converted into oleum. See, sometimes the question asked in students' mind, ma'am, ऑलरेडी सल्फ्यूरिक एसिड यहाँ पर यूज हो रहा है, तो हम सल्फ्यूरिक एसिड को प्रोड्यूस क्यों कर रहे हैं? बिकॉज टू सी स्टूडेंट्स, यहाँ पर आपके पास जो सल्फ्यूरिक एसिड यूज हो रहा है वो बहुत माइन्यूट क्वांटिटी में है. ओनली स्प्रे इज डन, and with the help of sulfuric acid we produced oleum here. So this is all about the process of contact process, and it is very, very important process. Now the oxo acids of sulfur. See, the first, this structure, it is H2SO3. I am again repeating, H2SO3, and it is called as sulfurous acid, and its basicity is 2. This is the structure of sulfuric acid. H2SO4, where basicity is again 2, because 2 hydrogens OH bonds are there, and it is very important, H2S2O8. It is called as peroxo disulfuric acid. I am again repeating, peroxo disulfuric acid. Why it is called as peroxo? Because here peroxide linkage is there. Oxygen is joined by a single bond and it is called as peroxide linkage. So it is called as peroxo disulfuric acid and its molecular formula is H2S2O8. The another structure is H2S2O7 and it is called as pyrosulfuric acid. It is formed when two sulfuric acid combine together and there is a loss of one water molecule. So we have four major oxo acids of sulfur: sulfurous acid, sulfuric acid, peroxo disulfuric acid and pyrosulfuric acid. Structure of sulfur. See, sulfur exists in two major forms, S8 and S6. In S8 form, it remains in crown structure, and in S6 structure, it forms cyclic chair-like structure. Allotropes of sulfur. Sulfur remains in two forms, rhombic sulfur and monoclinic sulfur. Rhombic sulfur is called as alpha sulfur and monoclinic sulfur is called as beta sulfur. See students, at 3969 Kelvin, rhombic sulfur and monoclinic sulfur coexist. So this temperature is called as transition temperature. Now first we are discussing with rhombic sulfur. It is the most stable form of sulfur. It is obtained slowly, evaporating a solution of roll sulfur in carbon disulfide. When octahedral crystals of rhombic sulfurs are formed, it is lemon yellow in color. It is lemon yellow in color. Now the monoclinic sulfur. If crystals of rhombic sulfurs are slowly heated to 369 Kelvin, this slowly changes into needle-like structure and that variety is called as monoclinic sulfur. This form is stable above 369 Kelvin. This is dull yellow in color and it is insoluble in water. Now the important questions generally asked in board exam. The first question is, what happens when the SO2 is passed through the ferric solution? See, as we studied that SO2 is acting as a reducing agent. See, if it is acting as a reducing agent, it converts ferric into ferrous ion. The aqueous solution of ferric solution changes into ferrous. SO2 is acting as a reducing agent. When it is passed through this aqueous solution of ferric salt, it reduces into ferric into ferrous ion. That is the reducing property of SO2. So if in paper it is asked, discuss the reducing property of SO2, you can take the example of ferric ion. Now the next question, how the sulfur dioxide gas is detected in lab? See, if we have to detect the sulfur dioxide gas in a lab, it passes through to acidified solution of potassium permanganate, which is pink in color or purple in color. On doing so, the sulfur dioxide, being a reducing agent, reduces purple color to colorless solution. So the solution changes into colorless and we can detect the nature of the gas, it is SO2. And if we are discussing about the oxidation state of manganese changes into +7 into +2 oxidation state. Why the value of Ka1 is greater than Ka2 in sulfuric acid? In your mind, the question arises, ma'am, what is Ka1 and Ka2? It is the dissociation constant of sulfuric acid in first step and in second step. So first of all, we are discussing with the help of equations. If sulfuric acid dissolve in water, as it is acidic in nature, hydronium ion is formed and its value is very large. In second step, when the second hydrogen has to release to form a hydronium ion, the value is very low because it is in first step, it is it releases hydrogen ion very fast. But in second step, removal of hydrogen from the ionic species is difficult. So the value of Ka2 is lesser one. The larger value of Ka1 means sulfuric acid is largely dissociated in first step, and greater the value of dissociation constant, stronger will be the acid. So students, in this whole slide, we have discussed how the SO2 is produced, then SO3 is produced, how SO3 is helpful for the production of sulfuric acid, and the questions related to sulfuric acid. Thank you, students, for listening me.